Hello. In the first video called Part 1, we discussed a simple trigonometry around the circle. At the end of it, we discussed small angles. As an example, we considered angle pi by 6, and we saw that displacement around the circle and distance, which is the length of the arc, and in fact, the Cartesian y-coordinate of b defined by the sine function, are very close to each other. The difference becomes negligible when angle is small. By the end of Part 1, we discussed approximation of sine and cosine functions near zero. In this video, we'll view it in more details. The graph of sine function on the left, it's almost a straight line near zero. But then it starts curving down, which is the second member of the Taylor series, shown in magenta color. As x moves further from zero, further members of the Taylor series become influential, but we're not going there in this video. Do we even care about x in the power of 3? Not for our purpose, but yes for other purposes. In fact, the following sequence solved by Euler in year 1735, one of the most elegant tasks ever solved in math. And the way to prove that formula was exactly by using the second term in the Taylor series for sine. So now in the right is graph of cosine. It looks very parabolic. So the main purpose of this lesson is to show that for cosine, when x is near 0, its deviation from the 1 is x the power of 2. We will need that when we talk about a pendulum. So far, we discussed the behavior of sine and cosine functions in domain near 0. But in fact, for our further purposes, we need to know also the behavior of those functions in the whole range, from 0 to 2 pi. And further, every 2 pi, behavior repeats. We already saw their graph, but we need to learn their arithmetic. That's the second half of this video. Yes, I was aware we started from simple travel around a circle and got into very advanced stuff. We quote Taylor series before many of you even learn of derivatives. Now, trigonometry arithmetic, which I'm trying to introduce right now, matrix and vector. Also advanced concept in math. Please ask your questions. I'll try to answer them. In this picture, we see O as center of the circle, and A0 is the starting point of travel around the circle. It lies on the x-axis, which is convention. When we rotate initial vector by angle alpha, we use Cartesian arithmetic, the middle equation here. And then we rotate this vector by additional angle beta. Same arithmetic, the bottom equation here. But we can instead start with initial vector and rotate it by angle alpha plus beta. If you expand all the equations, you arrive to arithmetic, highlighted here in blue, for sine and cosine of alpha plus beta. We also can introduce a matrix rotates a vector by random angle alpha. We apply matrix T alpha to vector OA0, and we get vector OA alpha. Let's also look at point A minus alpha. Prove to yourself a sanity check. If we take vector OA minus alpha and apply matrix T alpha, we should get the original vector OA0. Same about T minus alpha applied to vector OA alpha. Use Pythagorean theorem to prove it, and obviously matrix T alpha multiplied by T minus alpha should yield unitary matrix. We are already over 3.5 minutes. In the next video, Part 2, ABC, we will finalize about derivatives of sine and cosine functions and answer your questions. Thanks for watching.